I like this very much.
Yes, let's go to the slide.
Whee! This is so much fun.
Yes. Oh, do you see that as well?
Oh yes, people are pulling water out of that well. Let's go there.
Let's go.
Oh, what is this wheel?
Oh, that one? On which the rope is moving?
Yes.
This is called a pulley. It helps to pull out water easily.
But how?
Let me show you.
Let me pull it. This is so difficult.
Oh, now try to pull this bucket.
Oh, it is easy to pull.
You know, you could pull it because of the pulley. This is called a simple machine.
What are machines?
The instruments which make our work easier are called machines. There are machines like cars, fans, but those are complex machines. But pulley is a simple machine.
The instruments which make our work easier are called machines. Oh, can you show me more simple machines?
Yes, in this garden only. There are many simple machines. Come with me. See, this is also a simple machine.
A slide is a simple machine.
Yes.
Wow, they are using a slide to load the material. And it looks so easy.
Yes, this is called inclined plane also. See, this makes our work easy.
Yes, that is why slide is called a simple machine. Inclined plane.
Whoa, did you see that? How fast he went.
We are going on foot. He was on a cycle.
Yes, cycle also travels fast because of its wheels. See this tempo. So, wheels helps to travel and carry load.
So, wheels are also simple machines. Wheel!
Oh, see here what the gardener is doing.
He's trying to move a big stone with a rod.
Yes, this rod is called lever.
Oh, lever?
Yes, let me show you its different parts.
Lever? Hey, it is fixed at one point.
Yes, the fixed part is called fulcrum. And see, he's putting force with his hands. It is called effort.
What is stone called here?
Oh, it is called the load. Do you know there are many kind of levers?
Many types of lever?
Yes. See, fulcrum is on center here. And see here.
Oh, effort here is by the person.
Yes, but fulcrum is on the other side. And load is in the center.
Yes, in first one, fulcrum was on the other side. And here, it is in the center.
Let me show you.
Oh, here effort is in the center.
Yes, load is on one side and fulcrum is on the other side. Let's see one. Now, can you tell me where's the fulcrum on this simple machine?
Oh yes, it is the center. It is fixed.
And where the effort is put?
Effort is put from the back and load is on the front.
You know, this is also a simple machine.
Yeah, it looks like a nail.
Yeah, it is a nail with groove. Can you tell how these grooves help?
Hey, the nail can come out easily, but with grooves, it can't come out.
Can you tell any use of it?
Oh, we can hang our clothes on the screws on the walls. Screw!
Oh, there are many more uses of it. See, the screw jack.
Oh, even my papa's car has one.
See, the screw in the jack moves and it takes the car up.
Hey, I did not know a simple screw can lift a car.
Oh yes, that is why these are called simple machines. They can do big things but are very simple.
Today, I learned about pulley, inclined plane, wheel, 3 kinds of lever.
Let's now learn about a simple machine and its functions. A simple machine is a device for altering the magnitude or direction of a force. The 6 basic types are lever, wheel and axle, pulley, screw, wedge, and inclined plane. So a simple machine is used to apply a force at one place and get the result converted into another place. By using simple machine, we change the magnitude of the force. Means we apply less force to generate more force, or vice versa. We also change the direction of the force. So, we might apply force in one direction and we might like to get the force converted or applied into another direction. In a short while, we'll see what are these 6 basic types. But any machine which does not fall in these 6 categories is not a simple machine. Now let us see what these 6 types are. Probably you have seen a lot of them in your normal day-to-day life. A lever. We have used seesaws as a lever in the park. Inclined plane. We often see it. Our steps in our house is an inclined plane. Screw we see day to day. Wheel and axle we see it in our car and other automobiles. Wedge, for example, the axe. We use the axe to cut a tree. That's a simple example of a wedge. Pulley. We have seen pulley being used in the wells or several different machines. Now let us see what is a complex machine. A complex machine is a machine made up of at least 2 simple machines. So we combine simple machines to form a complex machine. This is an example of a complex machine which is using several simple machines. Let us see. This complex machine is using a pulley here, another pulley here, one inclined plane, and we see screws all over the place. So this complex machine is using a combination of several simple machines. And a complex machine needs to have at least 2 simple machines. Now we will be discussing various aspects of a simple machine using the example of a scissor, which we use in our day-to-day life. So let us see what are the parts of a simple machine. In this example, we are using the scissor to cut a tablet. So, our motive is to apply the load onto this tablet using this simple machine. So, the position where the load gets applied or we want to get the work done is called the load. Now any simple machine needs a position to rotate against. So the position against which it rotates is called the fulcrum. Now we need to apply the force or the effort at some place so that it gets converted via the fulcrum onto the load into a desired fashion. So the place where we apply force is called the effort. So in this case, the effort is here at the other end where we press the scissor with our hand. Now let us see some other technical terms. So it's very obvious that the effort arm is the length of the arm which is applying the effort, and this distance is always measured from the fulcrum. So the distance between fulcrum and the effort is called the effort arm. Similarly, the distance between the load and the fulcrum is called the load arm. Now, depending on the length of these arms, the quality of the effort applied at the effort end is converted at the load end. So, the term mechanical advantage of a simple machine is called the load arm by effort arm. Means this by this. Let's see an example. In this case, we have changed the length of the effort arm. So we have made it bigger and we have reduced the load arm by simply moving the fulcrum to the right. So now you can visualize that we can cut this tablet much more easily by applying little force here. So in this case, the mechanical advantage is much higher. Bigger the effort arm, smaller the load arm, more is the mechanical advantage. Let us see what is input energy. We supply effort at the effort end or force at the effort end to do the mechanical work we want at the load end. So the energy which we supply to the machine in doing the mechanical work is called the input energy. So in this case we are applying input energy, output energy. It's the useful work done or the energy produced by the machine at the load end. So in this case, the energy produced at the load end for cutting this tablet is called the work output energy. Now let us see the principles of a machine. We apply input energy at the effort arm and we get output energy produced at the load arm. Are they equal? For an ideal machine, they are equal. Means whatever energy we apply at the effort end gets completely converted to the energy at the load end. This is an ideal situation where there is no loss of energy. So we apply 4 joule of energy at the effort end, we get 4 joule of energy at the load end. But in real scenario, in case of real machine, this is not possible. So if we apply 4 joule of energy will get less energy at the load end. So in this case, efficiency of the machine will be 2 by 4 into 100, which is 50%. That means only 50% of the applied energy is getting converted into the output energy, and there is a waste of energy. Now, does real machine exist? So the ideal machine, or which converts the entire energy applied into output energy, never exists. That is an ideal situation because there are losses. For real machine, the efficiency is always less than 1 or less than 100%. So there are energy lost. In our example, we have shown that 50% energy is lost. Let us see where the loss comes from. Whatever energy we supply at the effort end, a part of that gets converted into the load end, the output energy, and there is a lost energy. Where does this loss go? We are pulling out the fulcrum, which is rotating and converting the input energy to output energy. This doesn't come for free. So there is a frictional loss on the fulcrum. The rotating parts of the fulcrum rub against each other. We'll see the details of the friction in the friction chapter later on. So this friction creates resistance. So part of our supplied energy goes into overcoming this friction. Otherwise the wheel will not rotate and the machine will get jammed. And that energy converts into heat and dissipates.